Welcome to Get Your FRQ On. This question is from 2009. It's question 1 and it is calculator active. In the question stem, we have a graph of a velocity function representing a student, Karen, her velocity from her home as she rides her bicycle to school some random school morning. In part A of this question, we are asked to find the acceleration at time t equals 7.5 and to give the appropriate units. Acceleration is the rate of change of velocity, and since the graph we are provided with gives Karen's velocity, what we're really asking for here is what is the slope of the graph provided at t equals 7.5. So to find that slope, the graph is just line segments, so it is really just going to come down to finding slope. The acceleration at time t equals 7.5 minutes is going to be the rate of change of v of t at t equals 7.5. So we can use the formula for rate of change. So to find the rate of change at 7.5, because it's a linear function there, we're just going to use the endpoints v of 8 minus v of 7 over 8 minus 7. V of 8 is 0.2, v of 7 is 0.3. It is kind of tough to determine if you're not paying attention. You can miss the fact that the y-axis is decimals, not integers, but it does turn out to be negative 1/10 miles per minute for the acceleration at t equals 7.5. In part B, we are asked to find and explain the meaning of the integral from 0 to 12 of the absolute value of v of t dt and to provide the units. Now, if you've done particle motion problems before, hopefully you've encountered this structure of the integral. When we take the integral of the absolute value of a velocity function, what that will represent is the total distance traveled in this case by Karen during the minutes t equals 0 to t equals 12. All right, so the meaning would just be the total distance that Karen rode her bicycle during that time period. All right, to find this integral from 0 to 12 of the absolute value of v of t dt, it is just triangles and trapezoids and things like that, but the structure, because some of this graph is below the x-axis indicating negative values for velocity, the integral we want is going to be the integral from 0 to 2 of v of t dt minus the integral from 2 to 4 of v of t dt plus the integral from 4 to 12 of v of t dt. And the reason this middle integral is subtracted is this is the portion that is below the x-axis. Normally, with a definite integral, area underneath the x-axis will count against you, and it would reduce the distance traveled, but we don't want distance traveled. Really what we want is total distance traveled, not displacement. Total distance traveled and displacement are two different things. Because this integral will turn out to be negative, it affects the displacement negatively, but it's going to affect the total distance traveled positively, so we need to make sure it turns into plus. That's why it's going to be minus this integral. From this point on, just use the graph to find the actual areas involved, and it turns out that the total distance Karen traveled between t equals 0 and t equals 12 minutes is 1.8 miles. In part C of this question, we are asked at what time does Karen go back home and provide a reason for why we know this. All right, so in the question stem, I believe Karen forgot her calculus homework. It's very important that she go and get that. But graphically speaking, how do we interpret what the graph is showing us to answer this question? Because the graph is the velocity, as long as Karen's velocity is positive, Karen is moving away from her home. So in order to identify the time where Karen turns around and starts riding back home, that would indicate where her distance from home is now decreasing. She's getting closer to it. And so really in the language of calculus is what we're asking for here, or what we're looking for, is Karen's velocity needs to change from positive to negative. All right, that would indicate that her velocity is changing from increasing to decreasing. I'm sorry, her distance from home is changing from increasing to decreasing. If we look at the graph, there's only one place where this would happen, and that is at t equals 2 minutes. There is a couple of other points on the graph where velocity is 0, but the way to interpret that would be that is when she is at home finding this homework. She hasn't left anywhere. Her distance from home isn't changing because she's at home. So in the language of calculus, Karen's velocity changes from positive to negative at t equals 2 minutes, and that's how we know that's when she turned around. In part D of the question, we are introduced to a second student, Larry. Larry is also riding his bicycle, and Larry's velocity is given by the function w of t equals pi over 15 times sine of pi over 12, and we are asked who lives closer. In order to determine who lives closer, what we need to do is figure out how much distance was traveled from when they left home to when they got to school, excluding any time that, say, Karen was back at home, because that was all wasted time for her. But the actual time it took to leave her home and get to school after she had returned home, that would tell us how many miles she lives from school. So what we're interested in here is the integral from 4 to 12 of this velocity function for Karen. That turns out to be 1.4, so Karen lives 1.4 miles away from school. Because this is a calculator active question, we can integrate Larry's velocity function from 0 to 12 by using our calculator. Turns out to be 1.6. So Karen lives 1.4 miles away from school, Larry lives 1.6 miles away from school. Therefore, Karen lives closer to school than does Larry.